you are running, taking the subway, taking public transportation, you will earn economy coin. Two cryptocurrencies that we have designed, economy coin, has a goal to promote green behaviors. And the originality of this cryptocurrency is that it's not based on a proof of work, but a proof of behavior. So it's taking green mobility. In the second topic, I will talk about Lcoin, a concept of local coin, which introduces the principle of geographical demurrage. And with this, we are able to emphasize a local economy and to have more exchange between people.
Hello, welcome to the 38th edition of TALK.CYBERCNI. Today, as often, I switch places and I'm at the Campus CET in Paris, which is a place where security people come together, and based on that, the place is obviously very secured and the network is also very secured, and therefore Valeria and I just had quite some problems of getting the setup running. But we hope that it's good now, and we just try to run normal, and let's see how this goes. So I'm super happy to welcome Valeria today for her talk on security aspects in the evolved IoT-Edge-Cloud Continuum paradigm. And as you know, the goal of the speaker series is to educate you, to bring you interesting aspects around cybersecurity, where you can think about, where you can get some knowledge, and we do this every month. So don't hesitate to tell your friends, invite them even to join today. As always, everything is recorded, so you can watch it also afterwards. And also, as always, we also have the Slido. The Slido URL is, as always, slido/talk38. It will also be available shortly, so then I can show it to you. And with that said, use the second channel, upvote questions, discuss with us, because then it's most interesting. And with that said, let me introduce Valeria. So Valeria Loscri is research director in the fund team at INRIA Lille, and she joined the team in 2013. From 2006 to 2013, she was research fellow at the Tidal Lab of the University of Calabria in Italy. She received her Master of Science and PhD degrees in computer science in 2003 and 2007 from the University of Calabria, and her HDR, so her habilitation, in 2018 from the Université de Lille. Her research interests focus on emerging technologies for new communication paradigms such as visible light communication, millimeter wave cooperation, and coexistence of wireless heterogeneous devices, and cybersecurity in wireless networks. And she's involved in the activity of several European projects and different kinds. She has been nominated to the 2021 Women Stars in Computer Networking and Communications and by the IEEE Communication Society, and she's in the editorial board of the IEEE Comms Transactional Information Forensics and Security. As the ComNet, ComCom, she's serving as TPC member in several primary international conferences such as ESORIX, CNS, Infocom, and also PERCOM. And she's action chair and scientific holder of Being Wise Cost Action since 2023. And since 2019, she is scientific international delegate for INRIA Lille. That's great. So lots of qualifications. And yeah, with that said, I hand over to you, and we're looking forward to your talk.
Thank you, Mark, for the kind introduction. And I am really happy, thanks for the start, to arrive with the amount of data to be treated. The silos were not interconnecting to each other. And another important problem is that as you can see, there was a kind of direct arrow between each silo, each vertical application, and the cloud service. So next. Why this is a problem? It is a problem because, of course, it is expensive from a user perspective. It is from an energy point of view with a huge impact. People, researcher, industry community started to regard to a different and evolved paradigm that is moving the services, the application closer from a geographical point of view to the devices that need to be served. Next one. So at INRIA, in my team, I am in the fund team, we focus on the edge part, as you can observe. So we regard cybersecurity aspects and resource allocation for IoT devices and far edge node. So I believe, next one, that the main positive points are quite clear. The reasons why European Commission is funding such type of project is quite clear. And by the way, we can observe such type of paradigm implemented, for example, in 5G. So it's not something that is abstract, that is just pertaining the research community. It's something that is really concretely applied with the 5G infrastructure. And to strengthen the data processing capability is, of course, something that is quite intuitive. And here I put also that it was done to address latency, that is true, environmental needs, that is true, security and privacy. But let's say if and how security and privacy are really addressed with this new paradigm. Next one. So now I will try to explain exactly these aspects. Next one. And I am a little bit provocative with this sentence concerning edge provides similar functionality and services as cloud. Next one, with this heterogeneity. Next one, with this heterogeneity, we have billion of interconnected objects. Next one, that are next one. As I said, heterogeneous with a high level of heterogeneity. And the problem is that either we decide to make the solution, the security solution general, but this means that we have to lower the level of security at the more constrained devices. This is not a solution, of course. Or otherwise, what we have to do is to sacrifice the generality to have a more specific solution. But this means still that we have more vulnerable devices. And what we are studying in this moment in my team is to try to understand how the vulnerability at more resource constrained and potential more vulnerable devices can impact at the higher level. Next one. And another important aspect that we try to address is that the quality of service, because when we implement a cybersecurity solution, of course, we cannot sacrifice the performance of the solution implemented. Next one. So basically, if we make a comparison between the edge network protocols and the cloud protocols, just to try to understand the difference, the impact, what we can observe is that in general, edge network protocols are lightweight communication protocols. In respect of cloud protocols that are heavyweight communication protocols. Next one. Another important aspect that has to be considered is that in the context of IoT-Edge-Cloud Continuum, one of the most important, let's say, approach methodology that is integrated is based on machine learning and artificial intelligence integration. And next one. This means that machine learning is introducing new type of attacks, or can be also used to improve existing one. Next one. So first of all, what we try to do is to try to understand at which extent the machine learning approach can be a problem, an issue in the context of IoT-Edge-Cloud computing. And for that, we proposed a few years ago a kind of taxonomy where you can observe we consider different machine learning approach paradigm, and we try to understand which type of attack we can implement with which type of machine learning approach. Next one. So basically, for example, if we want to perform passive attacks, that's line of principle are considered as injection attack, exploratory attack, or civil attack. Next one. So I will show you how we started to think about building an intelligent attack. So an attack that can evolve. And basically, before to present the attack itself, I present you a little bit the way we reasoned to arrive to such a type of framework. So first of all, we consider that an attack or a framework that is implementing an attack should be capable to target multiple communication protocols in the context of wireless networks. Next one. It should be capable to adapt to the environment. This means that, for example, if some defense approach is implemented, our smart attack, clever attack, should be capable to evolve and be harmful, be impactful also in this situation. Next one. In line of principle, we are interested to attack that require little knowledge. Why? Because if we need to implement attack that require too much information data to be treated, normally this requires a lot of sophisticated advanced hardware and a sophisticated algorithm, and basically even though it can be realized that the level of attack is with low interest in general, because it will be less impactful. Next one. Another important point that we considered is the capability to implement the attack in IoT devices. Because one remark that we can we may do in this context is that in line of principle, if we create an attack and implement them, we let them running in an IoT context, it's easy to make camouflage with similar devices. If we have devices that are too much different, too much advanced, normally they are more detectable, more easily detectable. Next one. So then these characteristics, these features typically could permit to create a framework. And now, next one, I will present you Harpagon. That is an energy efficient framework for attacks in IoT networks, and Harpagon is following exactly the type of features I just presented. Next one. Okay, Harpagon is a framework, and it is realized in a way to implement different type of attack. For example, eavesdropping, that is a passive attack one, and also an active one, the jamming attack. Next one. So is to focus on the focus on the interaction of the transmitter with so the victim node with the attacker node, and we are creating an interaction attacker transmitter model. Next one. So basically, the framework that I will explain is then based on identification of the IoT protocol. So what we do normally is that we analyze the environment, we focus on the target device, we try to understand based on a sniffing stage which is the protocol that is used. The protocol, of course, has to be based on the different stages I just presented, so transmitting, receiving, etc. And then what we can do is select the type of attack that we want to implement, if it's jamming, eavesdropping, replay, etc. Typically, we can also decide which type of strategy we want to implement, maximize, for example, the effectiveness of the success of the attack, or minimize, for example, the energy consumption, because we are implementing the attack on an IoT node. Next one. So, basically, as I was saying, what we did for Harpagon is to use the typical working, the typical duty cycle of vulnerability. Why as vulnerability? Because if we want to create, for example, an active attack, let's say a jamming attack that is effective and is less detectable, what we have to do is to try to understand when our transmitter is transmitting and intercept this stage and send packets exactly at this stage. Next one. So the goal is then to optimize the impact of the attack and minimizing the energy consumption of the attacker and also the detectability of the attacker. Next one. It is for that we started to think about a Markov chain representation because it was the one, the model, the approach that permitted us to represent the different states and the transition from one state to another. In this case, next one. Next one, because this is just representing the different states. Next one. In this case, what we are representing is the functioning of a single node. Next one. So I will not present the detail of the mathematical detail of the Markov chain. There is a paper that you can refer for that for the detail. So next one. But what is interesting to notice here is that we, as I said at the beginning, we are considering the same model for the transmitter and for the attacker. And what we are focused on is on the interaction of the two nodes. The transmitter is also transmitting. Next one. Next one. So we considered this interaction model through the representation of Markov chain. And let's say that Markov chain is at the basic of several machine learning approach. For example, in multi-arm bandit, it is used typically as basic Markov chain approach. And we decided to model the problem as a maximization of the attack effectiveness by minimizing the energy consumption. So basically, we can say we have a budget in terms of energy related to the attacker node, for example, and we want to maximize the probability of effectiveness by staying in this budget, or we can decide to maximize the effectiveness of the attack, trying to minimize the cost. That is not the same because we can still be more than the budget. Next one, so this is the once again the mathematical characterization, but next one. Next one. I want to present the implementation of that because we found out interesting that the implementation on the Raspberry Pi as IoT devices, that is reprogrammable devices, so that can easily represent an IoT node. This is basically the test bed with a transmitter, a receiver, an access point. So it's a real small network that we consider. And we decided to implement on the Raspberry Pi our Harpagon module and to evaluate the effectiveness by considering basically two metrics. And I will explain later on why packet delivery ratio and packet error rate. Next one. So basically here you can see the representation of the different stage when we decide that our attack is jamming. So I'm demonstrating the effectiveness in the case of the jamming attack in this case. Next one. After implementing our Harpagon attack, we started to make the networking working. And after 40 seconds, we started the attack. The attack, I recall, is a jamming one. And you can observe the effect of different jamming approach. We consider as baseline the constant and reactive. Just to recall, the constant is emitting in a constant way packets or signal at the same frequency of the transmitter one. The reactive is listening all the time and is reacting when transmission is occurring, etc. So etc. So it is much more impactful. And why is much more impactful in respect of reactive one? Because the reactive depends on the size of the packet. If, for example, a packet is too short, the time to switch the electronic component from receiving to sending, making sure that the effect of the reactive is really with lower impact. Next one. Since we were interested to implement an attack that is also not only less detectable, effective, but also in terms of energy more interesting, we decided to compare with some specific, to compare Harpagon with some specific algorithm attack that were implemented exactly with the same purpose, so to reduce the energy consumption. And we noticed that when the number of successful attacks is increasing, Harpagon is consuming less energy than also the other two baseline, learn jam and join jamming, presented in the literature. Of course, as expected, it is also more effective in terms of performance when compared with the constant one, but the constant one is just used as baseline because it is working well to destroy the network, but it is easily detectable, and it is consuming a lot of energy, so it cannot be kept for a long time. Next one. So basically, Harpagon is matching all the target features we considered at the beginning, because it is targeting multiple communication protocols. It requires some time to listen and understand the type of protocol and the specific time for transmission, reception, idle, and sleeping state. It can be implemented. We demonstrated that in IoT devices, and we were able to create a framework to select different things in terms of attacks. As you may observe, I didn't highlight adapt to the environment because as it has been developed as a Markov chain-based model. It can be extended with the machine learning approach in order to be adapted to the environment and make, for example, the selection automatically. But as I presented it today, is not dynamic yet. So next one, let's go to the conclusion. Next one, I presented the IoT-Edge-Cloud Continuum paradigm that is a new type of approach paradigm implemented in real network infrastructure. and that permit to reduce the cost to allocate the resource in a more clever way. But in terms of security, a viable solution for such type of paradigm. Next one. So thanks a lot for your attention. I will be really happy to answer to your question. In any case, if you want to reach me out, don't hesitate to contact me. This is my email address, so you can reach me out and I will be happy to interact with you. Thank you.
Okay, wonderful. So I really loved it, and you covered lots of different topics, and we also have quite some questions. So let's let me just check if the video is working as I expected. Just 1 second. Check. Okay, looks good. Okay, cool. So thanks a lot. First question, the Edge Cloud Continuum. Could you give a definition for what this is and what is the difference to environments that we had before? I asked this question especially with regards to the attacks, because my next question will be, you said this Edge Cloud Continuum now has new attack vectors, and you also showed them very well, but it would be cool to also have some really concrete examples of which attacks and which orchestration of the attacks you're talking about. But first, maybe you can say a little bit more about this Edge Cloud Continuum, what it, from a technological perspective, what it means, which devices are integrated, what communication technologies we have, what applications are arriving, and so on.
Okay. Yeah, I imagine that it's not easy to figure out which is the difference, but basically, let's say if you go maybe, I don't know if you are still sharing the screen, but maybe you can go to the slide 6, where I'm presenting the evolution from IoT to IoT-Edge-Cloud Continuum. And basically, the difference is that before we didn't have the two intermediate stage, the two intermediate layers, let's say the far edge and the near edge. And the were far away, we don't know where, etc. So when an IoT device that of course can be constrained in terms of resource was needing some type of service to run a certain algorithm, for example, the request was directly sent to the big data center before. Right now is not the same. Really, from a geographical point of view, the edge node and more specifically the far edge node are located close to the IoT devices. I was saying that it is something more concrete than we can think by citing, for example, the 5G infrastructure, because you know that with 5G we have the concept of G0B, that is a kind of edge node, we can say, that is located closer to the devices that is serving, and are in terms of weight more really stronger than the one that far edge node, for example, are capable to run, because far edge node are in some way intermediate nodes with sometimes more capability of IoT devices most of the time, but not with the capacity of a data center. And this is not of interest to replicate so many data centers. But this is also the problem, because this means that you cannot run and you cannot isolate from a cybersecurity point of view the far edge node as it was done for the data center before. So the type of attack that were the one of interest for the data centers, are not the same. And here, for example, the problem is that if you are capable to breach the integrity of an IoT device that is exchanging information with the edge node, the problem is that this IoT device is not isolated. It is in a network. It is exchanging information with the other connected devices. And then it has been demonstrated with the INRIA botnet, for example, that it started from a lower layer, but it propagated also up to data centers, the impact of the attack.
So to paraphrase it, and you will tell me if I forget something. I mean, of course I forget something, but if it's the key aspects. So we have low resource devices that are getting connected seamlessly with edge nodes that are more powerful, and then with the full internet, and therefore the weakest part of the chain is defining the attack vector or the risk. High-risk devices are suddenly getting powerful links and also access to powerful resources that can then at the end execute attacks. So are these key points of this edge cloud continuum regarding cybersecurity?
Yeah, exactly as you are saying, in the sense that it can, what we are analyzing, studying is how, for example, an attack that is generated at a lower level may propagate at upper layers as well.
Okay, cool. Then let's stick for a second with the concrete attacks. You said Mirai botnet, so this was an attack where you had lots of IoT devices that were doing the distributed denial of service attacks against infrastructure in the more powerful network, which is of course attractive because you have lots of those things, and if they're able to send messages, even just a few messages, and you have enough of these devices, it's of course very powerful. Are there other examples of attacks? Also, when we look towards your modeling, are you, because you modeled certain aspects, I think I noted it, like with the transmission, receive, idle, and sleep, and so on. So do you focus on certain attack types with your models, or what was your approach when you chose your models?
We focus on really physical layer types of attacks. For example, we focus on jamming and replay attacks. Basically, what is interesting is to study combination of different types of attacks. Because exactly on this type of attacks. Because it has been recently demonstrated also with a tool based on the implementation of machine learning approach that, for example, all the connected objects that we have at home, smart lamp or camera, etc., it is quite easy to implement replay attacks. And you imagine every time we connect a smart lamp, there are information that travel direct to the data center, to the far away data center. So once again, they are connected in a network. So if there is something that in terms of attack occurs at very low level, we cannot neglect the potential impact on higher level.
And when you say you focus on physical attacks, can you draw once again the link to this towards the cloud continuum? Because I fully understand that when you're on the edge layer, it makes sense because the devices are joining there and jamming and so on are attacks on these layers. But do you also correlate it with towards the cloud with other infrastructures doing something? Is this also something that is interesting to you? Also, the attacks are these. Do you also look at then higher level attacks that are based on these starting attacks in order to do something? Is this correlation also something that interests you?
Definitely yes, in the sense that since at the end we consider all the ecosystem, all the networked infrastructure. Of course, we can imagine that when you are able to replace a legitimate node that is at the intersection of the IoT devices and the higher layer devices, when you are able to replace this node or to clone this node and steal the identity and inject different type of messages, this is with impact in the two direction for down layer and upper layer. So definitely yes.
Okay, cool. I have two directions to go. I'm just thinking which one I go first. Let's maybe stick a little bit with the approaches. Are the collaborative approaches also something that is interesting and promising when coming from the direction of research you are coming from? Let me elaborate a little bit on the question. So, as you were saying, you use Markov models and so on. From my point of view, you're coming from a much more theoretical modeling perspective of detecting things than I am doing, because I'm more on the practical. We see some signals and do some machine learning and detect something. And so with me, something like federated learning, where models are exchanged, or swarm learning, where you have the same thing in a little bit more peer-to-peer fashion, are hot topics because it's something you can directly apply. It's doing something. When I think about modeling, it's not so obvious, but is it also a hot issue at the moment? Is this collaborative aspect something that is a promising research direction? Is it something you're also looking at?
Yeah, definitely yes. I'm thinking about, for example, distributed denial of service where you have several nodes, for example, distributed in different.
So what is very interesting to me is that your focus is already on attacks. So how can I model the attack? What is the attack doing? How is the attack getting more efficient? And then for me, the immediate next step is detection, where I'm a little bit more at home again. Is that also your goal, to create detection algorithms, or is it more the focus on creating digital twins of attacks, if I may name it like that? So to have an ideal model for an attack, which of course enables detection afterwards, but is your focus on the recreation of the attack and on the modeling of it? So to ask differently, which is the ideal end goal of this?
Yeah, I see. I see very well your question. And to be honest, the presentation was at the beginning longer than I did. And the second part was another type of attack to make a friendly jammer, to implement a friendly jammer as a countermeasure for illicit drones. And why I'm saying that, because absolutely the creation of the attack is something that will permit us to characterize the vulnerability, both at protocol level and at physical or also signal level, because we work a lot also on signal level. And when we are aware about how the vulnerability can be exploited to create effective attacks, this is what permits us to advance in the detection, to advance in the countermeasure, because otherwise it's a little bit hard, it's a little bit complicated to directly focus on a solution where you don't know exactly how the attack is working. So the idea is to have this first step, analyze the vulnerability, analyze or better select the vulnerability that has of interest, because as I presented at the beginning, vulnerability is of interest if it can be exploited to create an effective attack that is not requiring too much. So if we require at the moment a quantum computer to create an attack, we are not looking at that at this moment, because is less likely to happen. But what is intriguing us is really, okay, a vulnerability in the protocol, in the system, or at physical level that can be easily exploited to create effective attack. And when it is the case, it has to be studied, analyzed really deeper in order to propose then the countermeasure.
Mm-hmm.
And this is exactly our goal.
Mm-hmm. Very, very good, and also very interesting, because it's very complementary, and that's quite to what I'm doing, and that's quite cool.
Yeah, and just to add another point, for example, I quickly mentioned at that point in the conclusion, but we are working a lot on physical layer security and physical layer authentication. And PLA for physical layer authentication is something that is really important, in my opinion, for IoT. What we are looking for now is how to translate them in signature, to distinguish two very close or several very close IoT devices.
Mm-hmm. And that's a very good bridge to that line that I didn't follow before, which is who is expected to secure the thing. And you were just saying to add unique features to the devices, for instance, to have seeds that you can use for security or authentication and so on. There's always this trade-off of complexity and ease, and IoT is typically something where they always try many domains, but also IoT, for compatibility in quotation marks reasons. They are getting rid of any security stuff, and also for cheapness. From your observation of the evolution of the market, do you think the market is aware of the problem and is willing to invest in order to resolve the problem?
I think yes and no, in the sense that in the context of MLC SOPs, for example, we are working with a big company, Entity Data, and they work on 5G. They are pretty aware about the problem, and for example, is from them that they propose the specific use case related to the detection of jamming, because as I say, the jamming is not just the constant jamming. Jamming is basically used to create shadowing attack, to permit to perform advanced attack in terms of man in the middle or rogue node, etc. So by working with them, you realize that they are aware about the danger of this huge deployment of IoT devices, etc. From another hand, I would say no, because if you observe other, maybe also small company, they they estimate yet that they still estimate that the cost to guarantee security is too much in respect of the potential consequences of an attack. So please no and yes yet.
Mm-hmm. You were just, or we were a lot talking about attacks, and one important thing nowadays when it comes to attacks is generative AI, or to reformulate it, having fast access with some reasoning capabilities on the knowledge in the internet, and this enables also to automate the creation of attacks. And as you have a very low layer, for me, it's not necessarily at hand that this threat already arrived at your layer, because in order to do a physical layer attack, you have to be physically close, and just as a matter of scale, there are not so many people that are physically close. But is this already an issue that is investigated in your community, looking at how can I automate the creation of attacks using generative models, for instance?
Were typically related to malware installation. There are some very few words yet, but that are regarding the possibility to implement such type of attacks through network. So it is to say that when you formulated your question, you were saying you have to be close to the device. It does depend, not necessarily, in the sense that it can also come from a little bit farther.
Mm-hmm. Mm-hmm.
And generative, what do you mean exactly with generative AI or generative?
Yeah, exactly. So what I mean is, you type into ChatGPT, I want to jam a LoRaWAN signal, and I have the following hardware. Please generate me some code, and then I can execute it.
Okay, let's say that ChatGPT, based on my knowledge, is capable to generate things that already saw. So if it is something that it already saw, it can be a good basic. But I believe that then it's a continuous evolving, new vulnerability, new attacks, and then new detection and countermeasures. So it is an evolution, a continual evolution. So it can be used as basic. Say that I don't believe that more sophisticated attack can be just based on generative AI.
Mm-hmm.
Not for the moment.
Okay, at the same time, it's what is to me the most relevant thing why it's necessary to consider is the scalability and the not needed level of skill by the attacker. Because if you have some thing that is able to generate your code, even if it would just be stub code for attacking a LoRaWAN stack, for instance, because this one you will definitely get, it already enables people that did not necessarily have access to creating such attacks to the technology. So this is rather the point of view that I have for the moment.
Absolutely agree with that point. This is the problem of integrating machine learning and artificial intelligence at each level. So absolutely agree with this point. Yeah.
Then another thing, we already talked slightly about it, but I want to deepen a little bit on that. You already said you have higher level security protocols, or higher layer security protocols on a higher ISO layer that are doing something. Are cross-layer investigations also something that is relevant for you, and how is it reflected in the models, these cross-layer aspects?
Let's say that in the team where I work, we are not looking to to cloud-based attacks or to upper layer attacks.
Mhm.
The cross-layer aspects are related more on the propagation of attacks that generate at lower level. So if we have some lower level attack, that the system.
Mhm.
So is with this perspective that we make research at very low level, and we are focusing on physical layer security, physical layer authentication approach.
Mhm. Okay, cool. Inspired by our discussion, I was thinking about a question that could be very interesting and that could also become a standard question in my series, which is, what is your favorite attack? And behind this question, to also give you a little bit time to think, behind this question, what I would love to get a little bit from the people is some interesting techniques that they have seen in their research an attacker was doing, some combination of different aspects, something like that. So do you have a favorite attack? Do you have something where you would say, okay, this is interesting to share with the audience because it is really interesting aspects?
In terms of attack, favorite one, I would say a combined one because we are really looking to combining smart jamming with man-in-the-middle attacks.
Mhm.
I believe that through these combined attacks, you can create different types of interesting attacks. So, if I would choose some attack, I would say the combination of these two, smart jamming with man-in-the-middle attacks.
Mhm.
Yeah.
And it's also very good because this series is also to educate people. And already by just thinking about the combination of the jamming man in the middle, it's something that will probably kick at least some people in the audience a bit out of their box because they typically have man on the middle on layer 3 and not on layer 1 or 2. So it's I really like it. Very good. Um, do you also measure? So and if you measure, how do you measure what? And I'm especially thinking about this energy aspect that you had. So what if you I don't know if you measure, but if you measure, what is your setup? Do you have, I don't know.
It does depend. For example, in the attack that I just showed before, we realized that just measuring packet delivery ratio, for example, was not enough because it was um, we had similar behavior for reactive jammer and our jammer, but is not enough because communication protocols are more complex than that. So there are mechanisms where you resend request packets. You need really certain level of certain amount of corrected received packets in order the network to work. And it does depend a lot of the application, but in general, what we do is based on the type of application. We also regard which is the most interesting thing to measure. For example, for the other type of attack that I didn't demonstrate is a friendly jamming attack, so is in some way the solution, the countermeasure for drones. We were measuring
To motivate lots of the people in the audience to go a little bit deeper into the directions you're doing your research. And if I'm now a bachelor student or a master student, what courses would you recommend to me? So what are the skills that I should acquire in order to do research in the directions you were describing in your talk?
But I would say to be curious about the connected object that you use. So you use a lot of IoT connected objects. You should be curious to understand how these work, which are the technology undertaking this communication. So you should be really curious to understand what you use, how it works. And then when you start to think about that, because, for example, something that is really interesting is that is not only among bachelor students, but also more adult people. Sometimes they completely neglect the fact that all the data that is circulating and that I say is the new gold today. Data is really precious resources. And when you don't understand that you are in some way giving away your data, and this is something really precious, I say start to reflect on that and to think about that. And the data are given away when you use your smartphone, when you have your connected camera, when you use the camera on your laptop. So when you have your smartwatch, all the connected objects that we use today are let me simplify a little bit, but the means to generate and send data on the air. So start to think about that, and then I believe that somebody could be really start to be passionate about that when they start to think in this way.
Mm-hmm. And I really like that, because what is always fascinating me is also this relevance and impact of my work for the society. And even though in your case it's the second step relevance, in the sense that for people it's not so obvious because they don't appear or don't see jamming every day and stuff like that, it's indeed of super profound importance what you're doing, and therefore it has super high relevance for the people. And I also think that this is a very good motivation. Very good. Cool. So yeah, thanks a lot, Valeria. It was a great session. Like, we could have departed in many more directions. I would also have loved to talk a little bit more about the modeling details, how to choose aspects of models, what is digital twin for you, and so on. But time evolved, so we can keep that for future discussions. So
Sure.
thank you very much. It was a
Thanks
great
a lot.
pleasure. And also big thank you that you managed to do such a solid talk after the technical difficulties we had at the beginning. Great job.
Thank you very much for the invitation and for dealing with this series that I believe is really something amazing. So thanks a lot for all the work that you do in this